Hey, this is Josh, part of the Practical Math series. Today I'm going to be working on proportions. And really what proportions are is they're an equality of two ratios. And what they're really trying to say when they say that even is just that whatever you have on one side of this thing, or equal sign, has got to be equal to the other side, all right? Now, yeah, if you had something like 6 equals 6, you'd go, duh, yeah, obviously 6 equals 6, so this is pretty easy stuff. But we're going to do it with some unknowns and fractions because it's a great skill to have if you're moving on in math. This is going to show up. I'm even going to do a second video, so I think I'll call this one part 1 and the other one part 2, where I get into even more, I guess you could say more complicated proportions, ratio types of problems. Okay? It all has to do with setting it up. The nice thing about the basics of this and learning these is that they usually give you the problem as is, so that you don't really have to think too much about it and just copy it here. And then we can work through it. Now there's different ways to do these. And yes, with a lot of these ones, even some of these basic guys, yeah, you could probably eyeball the answer and say, okay, well, you know, if I double this, then I just double that, right? I mean, that's really what you're doing. And if you see those patterns in the numbers, then I say use them, but eventually the numbers are going to get more complicated. What if this was negative 2.74? Now it's going to be a little bit trickier, okay? So just because you can eyeball it doesn't mean that's the only way you should use or the only skill you should use out of your toolbox, just because things are going to get more complicated, okay? And I don't want you just taking the easy route. So let's use the cross-multiplying, cross-products, whatever you want to call it, method. It's very reliable, and yes, you can use other methods as well. So I'll kind of talk through those, but I prefer the cross-multiplying way just because I don't know if that's just how I was taught, but it just seems very reasonable. It's quick, efficient, and gets the job done. So the cross-product or cross-multiplying way is to do exactly what I said, which is to cross-multiply these things. 1 times x is 1x. 8 times 2 is 16. You don't really need the 1 there because it was just a single unit of x, so you could just say x equals 16 and be done. Now, as I was saying in the beginning, you could just say, oh, well, what gets 1 to 2? Well, you times it by 2. And then what gets 8 to this? Well, you times it by 2. I do another couple lessons where I talk about scale factors and stuff like that, and this is very similar to that. You could think of it as this. And in class I even draw these like imaginary boxes. So if you're going this way, we would multiply. If you're going this way, we would divide. And what I mean by that is there's this magic number that would go in there, your scale factor. So 1 times what is 2? 2. Therefore, 8 times 2 is 16. Going back the other direction, 2 divided by 2 is 1. 16 divided by 2 is 8. It's a very handy way for working on these, and I even tell my students, draw the arrows right in the multiplication and division signs, because that's going to remind you, oh yeah, if I multiply 1 times 2 to get 2, I need to multiply 8 times 2 to get 16. And this works very well when it comes to those scale factor problems, like if you have like the two different, you know, heights of the tree, like this is the tree and then this is the shadow, and you're comparing this to this and this to this. I got other lessons where I do that. I don't want to get too off topic. But it is the same thing, okay? This is just more of a visual form of that type of problem, whereas this is more of a concrete, here's the math, crank through it, tell me what you get. As I said though, it's a really good skill to have because you're going to need it for more complicated lessons later on in life. Alright, so we solved the first guy, that guy's done. Let's move on. And again, if you feel like you're kind of already moving in the right direction, pause the video, try the rest of these problems, see what you get right, see what you get wrong, and then check. Okay, you really, and I know I say this in so many of my videos, but you are going to learn by making mistakes. 3/4 equals 21 over c. Again, if you use that method with the arrows and the division and multiply, you could probably say to yourself, well, 3 times 7 is 21, if you're up on your math facts. Therefore, 4 times 3 is 12. Now I've balanced this thing out. But instead of going that route, I'm going to go this route. Sorry, I used the same color. Okay, so 3 times c is 3c, and 4 times 21, well, yeah, it's 84, but let me just double check. Let's see here, let me clear this thing out. 21 times 4 is, yeah, 84. If you're allowed to use a calculator, I say use it. Not necessarily just to get the answer, but sometimes it's good. Like what I did, I used mental math to get this problem. 4 times 2, there's nothing being carried, so I can just do 4 times 2 and get an 8, 4 times 1 and get a 4. But then check it with your calculator. So if you're in that type of a classroom, I say try to do it mentally first, and then check it with your calculator just to reinforce. And if you get it right, then that's great, because it shows that you really are building some extra math skills. 84 is the number that goes over here. And now we're isolating the variable. Remember, it's 3 times c, so we do the opposite of multiplying, which is dividing. Sorry, that got a little sloppy. Those cancel out. As always, again, I'm hoping you're watching my videos. You're remembering these ways of working through these. We read our fractions down. 84 divided by 3 equals, I don't know, let's use the calculator. Yeah, you could do it longhand and it would take you a couple minutes, but let's use technology. And we get a 28. Okay, so c equals 28. And you can check the problem. 3 times 7 is 21. 4 times 7 is 28. So it does work. Now I don't want to feel like I'm going too fast through these, but the pattern is the same all the way through. And so again, if you feel like you're getting the hang of this, pause the video, try the next problem, okay? See what you get. Let's see here, 4 over 16 equals a over 8. As I said before, if these are decimals or negative numbers or whatever, right, or like 5 square root 2, it doesn't matter. All that matters is that you follow the same pattern. Now, this one's kind of interesting because I got a lot of numbers that are similar. They're all divisible by 4s, okay? So could I take some shortcuts? Yes, you could. I think it really depends on what type of class you're in. I think that if your teacher wants you, if you don't have a calculator, then I would say try to reduce things if you can, or simplify fractions before you start working with them, because using a smaller fraction and cross multiplying is going to be a lot easier than, what if the 16 was up here? Now I got 8 times 16 and I got some gigantic number I got to multiply, and I don't even have a calculator. So if you're in a class where you don't have a calculator, I would say try to reduce fractions like this if you're good at that, or if you want to watch my videos, practice this stuff. Reduce your fractions to make your multiplying a lot easier. It's not going to give you a wrong answer. It's just going to give you a more condensed answer. So when you go to write your final answer down here, you're just a little bit farther along the way. And you probably don't have to multiply as many numbers. I don't want to get too off topic. Let me do my zigzag x's here. Let's see here. 16 times a is 16a. 8 times 4 is 32. And then we're going to divide by 16, right? It's 16 times 8. So what you do to one side, you do to the other. Those two cancel out. A equals, and I recommend, draw these circles. It's going to remind you what to multiply. Draw this arrow. It's going to remind you. We read our fractions down. 32 divided by 16 is 2. Could you check your answer? Yeah, you could, right? We've done that a couple times, and so you can check your answers with these. Some of the nice things about these equations that you work through is just the fact that you can actually check your work. So before you turn in your test, I always tell my students, like, I don't see why you wouldn't check these problems and know that you're getting 100% on the test before you turn it in. I mean, spend an extra couple minutes if time is not of the essence and check your own work, right? You should know what you're getting on these things. So this one I wrote down just because I thought it's a different way that they're worded sometimes in books, 2/3 and 10/20. And the question is to tell us whether this is a proportion of equality. What did this book call it? Every book kind of calls these things different. Tell whether the two ratios form a proportion, and then they want you to explain. Okay, so they give you the two fractions, and then they ask you whether it creates a proportion or not. Take them, put an equal sign in between, and then see if there's something that you can do to multiply and come up with something similar. Okay, and this gets back to making that little box. Okay, and so let's see here. We know that this is going to be multiplying because it's going to get bigger, and it would be dividing to go that way. So 2 times 5 is 10, 3 times 5 is 15, okay? So in this situation, the answer would be no, it's not, okay? Because we don't have the same amount going over the top as we do on the bottom. Numerator, denominator, sorry, technical terms, okay? But this is a great way for you to be able to check whether they work. Both this magic number, scale factor, if you're doing this with scale factors, which is what it is, if you're doing this type of a problem, if you multiply the top by that number and you get this, but you don't get the same equal thing down here, then they are not equal. And so I guess you could explain it just saying exactly what I said. By multiplying the top by a scale factor amount and getting that answer. If I use it on the bottom and I get a different number, then it is not a proportion. Okay? So we've gotten through all these. Oops, I didn't check all these. Let me check them right now so I look really efficient. The next thing I wanted to go through was just a couple, again, just some very straightforward word problems, okay? The first one is if 18 copies of something cost $1.08, then how much would 40 copies cost? Okay? Now if it's given to you in a word problem manner, or just as I said it, then the biggest thing, or the most common way that people make mistakes, is this and this, okay? You need to match up the things that you're comparing. So if it's copies over here, it's copies over here. If it's bucks over here, dollars, sorry, then it's dollars over here, okay? And you can just put in an X as your variable. That's how you need to set these up to actually see how they're gonna work, okay? And then from there, you can now work through this problem. But like I said, you gotta set these up the right way, because I've seen students flip-flop one of them, and then they get these wacky answers, and everything goes wrong. So I'm gonna make my little things here. I'm gonna get 18 times x is just 18x, and then I have 40 times $1.08, or 1.08. So 1.08 times 40 is 43.2. All right. And from there, I need to isolate the variable. This is 18 times x, so we divide by 18. So x equals, I don't know, let's just divide it. Again, there, that was actually pretty cool. 43.2 divided by 18, I'm just using my calculator. If you can't use a calculator, it'll take you a little bit longer. And I get an answer of 2.4, okay? So from here, you got to take a look at that answer and say, okay, is 2.4 going to really be my answer? Does that sound about right? Well, kind of. Let's talk about the first thing that you're definitely going to need to do. If this is dollars, this is dollars, exactly. So, I don't know, maybe you're in a class where you're going to lose a partial credit or something, you know, because you don't put this into dollar format, all right? 2.4 is not really in dollars format. What the teacher probably wants you to do is write it as $2.40. Okay, that looks a lot cleaner. You now have copies to dollars, copies to dollars. Now, we can eyeball this thing and just kind of look and see if it looks about right. So we have 18 copies over here, which is, you know, if I round it up a little bit, I'm at about 20 copies, okay? And the reason I chose 20 is because this is 40. So if 20 copies or so is about $1.08, then 40 copies should be about double that. All right, so let's see. So is 240 about double that? Yeah, it's close enough. You know, it's not exact, but then again, I kind of rounded this guy to 20. So you can kind of spot check this problem just to see if you're on the right path. All right, let's get through this last one here because these are some of the ones that come up a lot, and so I thought it would be worthwhile to share a couple of these guys with you. Okay, so I'm going to buy 3 posters at how much? $9.60. And then the question is, well, how many posters can I buy for $48? Okay, well, just like I said before, and if it helps you to put in these arrows, then do it. If that's going to remind you, or if it helps you to write in right here, posters. Okay, because that's what you're looking for, that's where you're going to put your variable in. Now I want posters matching posters, dollars matching dollars. If you flip one of these, you're going to get some wacky answer and things are going to go sideways. All right? So now I have my proportion here. I'll just use one. This is fine. I'll just use that color. I know I'm going to color coding this. I like using colors. I feel like it helps, you know, people that are visual really see what the heck we're doing in all this stuff. 9.6 times x is 9.6x. 3 times 48 is like 5 times 3 is like, I don't know, like just under 150. So, but let's be sure. 48 times 3 is 144. Well, that's a nice number. All right. Again, I'm using a TI-83 calculator. You could be using a 10 key with this. You really don't need much. My personal belief is that you probably don't need a scientific calculator until you're like maybe Algebra 2. I've done Algebra 1 for many years with a 10 key, basic 10 key calculator that has the square root button and maybe it has like a square button so you can square a function. It takes me a little bit longer, but I think that it's also useful as a teacher to show students that it can be done with a basic calculator, just because then they're not thinking that, oh, well, the teacher or whoever, you know, I need this super expensive calculator to get me through all this. You know, honestly, like the TI, like Texas Instruments, like TI-30 or 32X or whatever that one is, anything like that will get you easily through many years of math. And then the only reason graphing calculators are nice is, you know, when you're getting into calculus and you want to see graphs of stuff really quick. But nowadays there's online apps too for that. Sorry to get on a side note there. It's just, you know, I don't want to show you like I'm using this super high-powered calculator and make it sound like you have to have a calculator like that for work like this, because you don't. Those cancel. 9.6. Read our fractions down. 144 divided by 9.6. So I'll take that number divided by 9.6, and I get a 15. Oh, that's crazy. It was a nice and even number. And you never know, right? Because who would have thought 9.6 would go into 144 like 15 equal times? It was a 15, right? Yeah. Just checking, right? As a teacher, I mean, I make mistakes too. I know I make mistakes. And every once in a while I do that. It's hard, you're talking through all this stuff at the same time. Okay, so I know this is all messy now. I'm going to put a 15 right there. Okay? The way to kind of quickly eyeball this thing is to think about it as that magic number. 3 times 5 is 15. So this is like almost like $10 here, right? It's close enough, right? So 10 times 5 is 48 or about 50. Yeah, that looks about right. So you can check your problems, okay? You can use this method. And if it helps you as well, like I said, to put in the multiply, because 3 times 5 gets you a 15. 10, right, we kind of rounded it. 10 times 5 is going to get you to about 50. All right, so we went through the basic proportions, then I started getting into a couple word problems here. I'm going to make a part 2 that's going to go into these a little bit more in depth, but if you think you got the basics, then I think you're all set. So thanks for watching, check out more of my videos, and I'll see you out there. Thanks.